so 17 through 20, is that what I'm hearing? Some of y'all had trouble. No, these right here?
Yes.
Oh, okay. I did 13 through 16 because it was 17 through 20.
Oh, okay. Well, that would be a problem. Does somebody else need to see 17 through 20?
I could see.
Okay. So y'all remember that ln of E is 1. But guys, this is not 1 to the 0 power. I want to make sure you understand. This is not like you just replace that with a 1. It's when you actually bring down the 0. Let me kind of show you. It's when you bring the 0 out front, is 0 times ln of E, which is just the number 1. So this is just going to simplify down to the 0, okay? The other way to think about it is whenever you have a log with a base, and I'll just say a base of E, and then an E to the 0, it simplifies down to the 0. Remember we talked about that? And that is on today's notes, so I'll go over that again in just a second. So what's this one going to be? 2A. What's this one going to be? Now this one's different. So what I have here is E, and then I have log base of E of C plus 2. If this will write C plus 2, like that, okay? So what do you think that's going to simplify down? Right. This is supposed to be an E right there. C plus 2, very good. So this is when you have a base and then an exponent log with that same base of something, it simplifies down to the X, okay? And then this one's a little bit different, okay? So this is E, and then I have log base E, and then it's X to the 4th power. Do you see that? So you have to raise the power of 4 back up. So this is going to simplify down to X to the 4th. It is not 4 times ln of X, or whatever some of you might have thought. So it is just going to be X to the 4th. Okay? So is that good? You're fine with that? Yes.
I have a different question.
Yes, absolutely.
Like any of like 31 and
31 or 35. Okay, let's go down to that. So 31 through 35. Okay, these are more of the solving ones. Okay, so any of those in particular y'all want to do? 32. Okay, because I figured some of you might need to see it as well. So what I'm going to do is I'm going to condense the left side, and I'm going to use division. So I have 5 over X is equal to 3. So I condense the left side, and now I can rewrite it as an exponential. So I have a base of what? E, right? So it's going to be E, and that's not really ln of E, but I'm just writing that to kind of remind you. It's going to be E to the 3rd power is equal to 5 over X. So E to the 3rd power is equal to 5 over X. So then I'm going to do what to solve for this? I can just truly exchange places with the X and the E to the 3rd. So X is going to be 5 over E to the 3rd. Now, if you don't have the calculator, you leave it just like that. This would be considered exact. And then you would use the calculator to get the approximate. I can't remember what the answer key said, but
He said X equals 5 to E to the negative 3rd.
okay, and that is the same thing, but I would prefer not to have the negative 3, but that's the same exact thing. Okay, yes.
So why did you guys switch the X and the E?
Why did I switch the X and the E? Okay, it's something when you have an unknown in the denominator, you can actually switch it with the opposite numerator. Let me kind of work it out by cross multiplying. So I have E cubed is equal to 5 over X. So if I cross multiply like that, I get 5 is equal to X times E cubed. And when I'm trying to solve for X, I would divide by E cubed. Cancel, cancel. So see how it works out? So it's just a little shortcut that once you get accustomed to using, it helps you and it saves you a step.
Does it always work?
It always works. When your unknown is in the denominator, it makes sense just to reverse it or exchange it with the opposite numerator. The opposite numerator. Okay, y'all tell me another one.
You have to take the exponent with you, right? When you're switching them.
Yes. Yeah, the whole numerator, the whole denominator, all of it. Any others in that section? Yes. 31. Okay, so for 31, how am I going to condense this side? So ln of 5 times X is equal to 1. There's an understood e here, so e to the first is equal to 5x. So x is going to simply be e over 5. Yes. 35. So 35, okay, I need to bring the power up first. Okay, so I'm going to bring that power of 4 and get rid of that. That's part of the condensing process. Is everybody clear on what I just did? But now, can I condense the left side as ln, and then it's going to be x to the 4th over x to the 4th, which is what? 1. Okay, did I go too fast? But it's not finished yet. And then I have to do e to the 0 is equal to, well, let's see. Well, e to the 0 is 1. Anything to, I guess, was that what the key said?
No, it had it in brackets. Yeah.
It had it in
It's like
brackets.
x is greater than 1 or greater than 0.
Oh, you know what it is? Where is the, okay. Okay, I got you now. So x is really what? Any number will work, is what's going on, okay? So that's why when I finished, there was like nothing to really do. So when I get down to ln of x to the 4th over x to the 4th, so let me not simplify it here, and that equals 0. Then I still have e to the 0 is equal to this. So e to the 0 is going to give me 1. But how many ways can you get a 1? How could x to the 4th over x to the 4th equal 1? Pretty much any x, right? Because 3 to the 4th over 3 to the 4th is 1. Okay? So that's how they're getting that answer. That's kind of an interesting problem. Let me see how they actually wrote the answer on that. So that was 32, 35. Okay, so for 35, it's any x such that x is greater than 0. And let me tell you why that's the case. Because truly, wouldn't it be any x should work? Because I don't care if it's a negative 3 to the 3rd, a negative 3 to the 3rd, it's going to cancel to 1. Here's the problem. It's with the original, let me go back here. It's with the original problem. I can't use a negative right there. Okay? So once I bring the 4 up, once I bring it up here and put it there, then any x really would work because any negative to the 4th power is going to turn positive. It's the fact that it's given to me in this form where it's ln of x. So negative x's will not work. 0 will not work. So it has to be x greater than 0. So when it says that, it's saying any x such that the x is greater than 0. It's almost like set notation, but any x, and this is saying such that x is greater than 0. That is a tricky little problem there. It's a good problem, okay? Yes.
So this problem has 2 answers or just
No, the answer to this problem is really any real number. Like if you look at it in this form, look at it here. You see that e to the 0 gives us 1. Well, what x to the 4th over x to the 4th is going to equal 1? Any x, right? That's the problem. But I cannot take the ln of a negative, okay? So, or 0. 0 won't work here either. 0 over 0 will not work here either. So it has to be something bigger than 0 because you can't divide by 0. That is a tricky problem, just trying to get you to see the concept. So I wouldn't worry too much if you don't understand like this writing of it. It's a kind of weird problem. It's intended to get you to think about like the domain, essentially, of the original problem. Yes? 30 what? 33. Okay, so could I condense the left side? Yes. It's ln, and I'm going to have 10x squared is equal to 10. Now, this is an e here, right? So e to the 10th is equal to 10x squared. So dividing by 10 first, and then I would take the square root. I take the square root of both sides. Okay? Now, normally you would say plus and minus, but will that work in the original problem? It actually will. Negatives actually will work in the original problem. Now, we probably want to simplify that down some. What's the square root of e to the 10th?
How would negative sometimes not work?
That one's square.
Because it's squared from the very beginning. See over here, see how x is not? A negative is not going to work here. But if I have a negative x here, it will work because I square it as part of the process. So let me just kind of see. This is
it just like have to be positive or something?
It has to be something, yeah, it has to be positive. When you're taking the log or the natural log of something, it must be positive. So, was that 35? No, that was 33. So here it is. So we had gotten to plus and minus. We had gotten to plus and minus under the radical e to the 10th over 10. Now what I was going to show you is, you remember that when you have a 2 here, it's just 10 over 2. E to the 5th, square root of 10 is still here, and it is the plus and the minus. Okay, so these are some good problems to get you to think through things. Now, then they put it in the calculator and got the answer there. All right, so tell me another one from the book. Any others? Nope. Okay, some of this we're going to kind of reiterate with the notes today. So pull out your notes from yesterday, flip to the back. Okay, so this is more on LNs. Now, I do want you to look at 302, 6 through 10, and see if you have any questions. Okay, so I had intended to sort of do that as a warm-up. So just real quickly, on your sheet of paper, you can even do it down here at the bottom. Go ahead and do 6 through 10. So it'll kind of be our warm-up for today's lesson. Okay, so 6 through 10, and y'all should be able to do that really quickly because we just kind of went over that. Okay, y'all probably have that, don't you?
What does 10 say?
Number 10 says, oh, I'm sorry. Number 10 says e raised to the 3 times ln of x. Okay, so let's go over it. And in fact, I'll just do it right here for you. Okay, so number 6 is going to simplify down to what? 1. Number 7, x minus y. Number 8, is that a negative? Okay, let's see. Is that an issue that it's negative? Nope, that's fine. Okay, how about the next one? 2x, and how about the next one? That one's hard to see, isn't it? So you have to bring the 3 up, so it's going to simplify down to x cubed. Y'all with me on that? Okay, so this was page 302, just kind of as a warm-up, 6 through 10. Okay, so I think you're getting that concept, so glad we went over that. Now let's just go to this page, and we're going to do some notes here. Now, this is on your note sheet, so you have this already. Just want to talk through making sure everybody understands these properties. So we just use them. But basically, log base e of e is always going to be 1, because e to the first will give you e. This we talked about, that's just going to be x. Now here it's an exponential with a log as the exponent. Okay, or this is like a power of a base of e with an exponent of log base of e. It's just going to be x. So we kind of just did some of those. Now, these are kind of the same type of things we did yesterday, but let's just do it with ln. Okay, so what would I do for the first example here? So ln of 3 times x is equal to 2. Rewrite it, so it's going to be e squared is equal to 3x. Divide by 3. So I'm going to say x is going to be exactly e squared divided by 3. And you can get an approximate in your calculator, but that's good for now. Now, this is really not ln with the base of e. It's really log with the base of e. That's just a little shortcut to show you what I'm doing there. Okay, what about the second one here?
8 over x.
And then e to the 7 will be equal to 8 over x. So x is going to be equal to what? They're just going to change places, remember? So it's going to be 8 over e to the 7. Now, I know the book said 8 times e to the negative 7. Usually you don't want to leave negative exponents, so I would prefer that answer. Okay, what about the next one? So e to the 10th is equal to 7x squared. Divide by 7. Take the square root. And very good. Now, will either of these work? Absolutely. So this is kind of like the one we did. It's exactly plus and minus e to the 5th over the square root of 7. Just leave it like that. Now, what about the next one? So x to the 4th is equal to 16. 2. Now, is it positive or negative?
Yeah.
Yes, it is. Positive or negative 2 is the answer there. Because if you do negative 2 to the 4th, it turns to a positive 16, etc. What about this next one?
Wait, did you add 4 to both? Add 4. Can't you take that 4 and add to the other side?
Right here? Yeah, you actually could. So you actually have a couple of choices. So you could add the 4 over, and then what would you do next? Divide by 3, right?
Yeah.
So the other option is you could bring this 3 up here as a power. You can do it either way. Okay, so let's go ahead and do it the way that Jack suggested, and then that's going to be 8. Divide by 3. So,
Can you do both? Like, then have x cubed equals 8? Does that make any sense? Like,
yeah, you could do both.
Okay.
You could do both. And then what would I do next? E, okay, because there's an understood e there. So e to the 8/3 is equal to x. Oh, I went off the page there. So e to the 8/3 is equal to x. Now, what if you did do it the other way? So let's get an approximation for this one. E to the 8/3. Just do it in the calculator. So I'm going to have e, and then just do 8 divided by 3. I don't know why it's not working. I think my calculator has frozen. Okay, I'll just go back and use this calculator. So it's going to be e to the 8/3. Can y'all see that? Yeah. Sort of. Okay. So second ln, and then I'm just going to do 8 divided by 3, and that's going to give me 14.39. Okay, approximately 14.39. I'm just curious. It doesn't seem like the other way is going to give us the same answer, but let's see what happens. So let's do it our alternative way. So what were you suggesting? ln of x cubed, add the 4 over, equals 8. So then it's going to be e to the 8 is equal x cubed. And then I'd have to take what? Oh, this is perfect. Yes, absolutely. Because this is going to be where I raise this to the 1/3 or take the cube root. And I would do the same thing there. Take the cube root, e to the 8/3. So see how you get the same answer 2 different ways?
And both these would be counted correct.
Yeah. Now, if it says exact, this is what we mean. It means you're not touching the calculator at all. Okay, if it says approximate, then you can use a calculator and you have to use the little approximate symbol. All right, so you guys have your, well, no, I didn't give you a review yet, so let me give you a review. Okay, and this goes all the way back to the graphing that we did. It's everything. Now, let me just kind of talk you through the next couple of days. Tomorrow we do have a little activity. with a partner that will be graded for accuracy. Okay? But today and Thursday is all review. Today and Thursday is all review.
Then Friday's the quiz, right?
The quiz is Friday.
Why is this review so big?
We just want you to do so well. Okay, the graphing piece, I think you'll be fine. Okay. So anything on the front page y'all want me to kind of talk through or walk through with you? It all just seems like it should be pretty straightforward. Okay. Which one? Number 10? So that's going to be, so for ones like that, you're just going to say you have your base of, so you got that? So you have a base of 10, it's just going to be 10 to the 7th is equal to, so you're just rewriting this. And that is right because you have 7 zeros. So that's just rewriting. Okay, so since we have today and tomorrow night and Thursday night, I would say do all that you know how to do today. Just work as hard as you can doing all the ones that you do know how to do. And then the ones you don't know how to do, we'll know to go over those. Okay? This is classwork and homework. So I would do as much as you can. Okay? You may listen to music at this point. That would be fine. So don't forget tomorrow we have our